As soon as a little, there we go. Retakes on the quiz. If you would like a retake, make sure you finish any missing assignments for 1.1 to 1.3. Correct the problems that you missed on a piece of paper or on a Google Doc or whatever online document you would like to use. And then email me a picture of your corrections or the Google Doc. You can just email me, share the Google Doc with me if you did it on a Google Doc. And then you have a week from now to submit corrections. And I will remind you guys, and I'll put it on the calendar and stuff like that. But you have a week from now if you would like to get a retake to submit your corrections. And then we will set up a time to make that retake happen. Are there any questions concerning retakes? Any questions on how they will work or what you need to do to get one? Okay. If you have a question at any point, feel free to either unmute yourself and say so or type in the chat and we can take care of that. Okay, so that is the process for retakes. Next, today we're going to be starting, well, yesterday we kind of started 1.4. If you had, if you looked over in the stream, you notice that the recap, we took our quiz. We also started 1.4 by watching the short 4-minute video. And then we had notes on polygons and what the different names for the polygons were. We also had convex versus concave and regular versus irregular and all that good stuff. My shirt today, we have a pentagon, hexagon, and Oregon. Or Oregon, the state. So that's a fun topical shirt. Anyway, or the dorky math teacher shirt, whichever one you prefer. So concave, just as a quick review, is something that has kind of dents in it. It's caved in somewhere. So like right here, this is the part that makes it concave. Convex, there's no dents. It's not caved in any place. And then we have regular versus irregular. Regular means they have all the same sides, so all the sides are the same length, and all the same angles. So the angles in the corners are all the same. Irregular has different sides and angles. So anything that's not regular. Also, just as a hint here, if you see something that is concave, concave things will always be irregular. So just kind of something to notice there. Anyway. Then we had a short IXL section about naming polygons. It was 8th grade 01. It's also linked right here. So that's the IXL section we had yesterday. Today, we're continuing with 1.4, and we're going to talk a little bit about perimeter, and then 1.5, which is about angles. We're going to start getting into some angle vocabulary. Okay, so let's get started. You need a notebook or paper and something to write with. And your warm-up is to classify the polygon by number of sides. So give it the name that has to do with the amount of sides. And then tell me, is it convex or concave? Is it regular or irregular? When you're finished with that task, type done in the chat. All right. Looks like most of us have it. What would we call this polygon? Type that in the chat. All right, we got hexagon. We've also got concave. And then is it regular or irregular? All right, we got irregular. Yes, all these words are good. All right, so hexagon, because we have 6 sides. 1, 2, 3, 4, 5, 6. Concave, because of this part right here that's kind of dented in. And then it is irregular, because the sides and angles are not all the same. All right. So for our notes today, we are going to be talking about perimeter and angle vocabulary. So we want to be able to find perimeter in the coordinate plane. We're going to be using the distance formula for that today. So we're getting extra practice with the distance formula. So this should help those of you who had trouble with any distance formula problems on the quiz. And then we want to be able to name angles. We're going to start with that today, or get started on that topic. And then we want to be able to classify angles as acute, obtuse, right, or straight, which you might remember a little bit of from earlier on in your math education, or you might not. Okay, so here we go. With the notebook paper and this thing, so you can see. Here we go. 1.4, 1.5, perimeter, and then angle vocabulary. So we've got, we want to find, that's a terrible writing, perimeter in the coordinate plane. We want to name angles. Classify angles as acute, obtuse, right, or straight. Okay, so that's where we are headed for today. First, we're going to deal with perimeter. So thinking back to elementary school when you probably first learned about perimeter, or maybe middle school, what is perimeter? Does anyone remember? Go ahead and type in the chat if you think you know what perimeter is. Outside, yes, it has to do with the outside. Right, you might have heard it as length plus width plus width. Kind of adding up all of the sides, right? So if it has 5 sides, you would, add up all the outside lengths. If it has 3 sides, you would add up the 3 side lengths, things like that. So it is the distance around the outside. All right. So if we were doing this without a coordinate plane, like let's say I just had some rectangle here. We know it's a rectangle because the 2 sides that are opposite each other are equal. And it's also got right angles in the corners, but we'll talk about that later. So if I have a shape that looks like this, well, first of all, using our knowledge that 1, it's a rectangle, and 2, the terminology or the notation that we learned last week, that these 2 sides are the same length because they both have 1 dash in the side, that these 2 sides are the same length because they both have 2 dashes in the side. So those would be my side lengths. So then my perimeter, I'll just call it P, is going to be 4 plus 4 plus 2 plus 2. Just adding all of the sides together. And 4 plus 4 plus 2 plus 2 gives us 12. So this would be my perimeter for that shape. Okay. So that was kind of the elementary or middle school version of this thing, right? You're given a shape, you're given the sides, you add them all up to give you the perimeter. The geometry class version of this takes it a step further, and we use the coordinate plane to do this, and we use the distance formula. So a problem that you guys might see concerning perimeter would be something like this. Find perimeter of the polygon with vertices. So vertices just means the points. These are all vertices. The corners are all vertices on that shape. 1, 1, 1, -2, and 4, 0. If you have graph paper here, you'll be at a little bit of an advantage. If you don't have graph paper, like I'm not using graph paper right now, you'll draw a graph like mine. So the first step, or the first thing I like to do, is draw the graph. You don't have to draw a graph to be able to do a problem like this, but it makes more sense to me, at least, when I draw a graph. So I'm going to go over 1, up 1 to get my first point. And then over 1, down 2 to get my second point. And then over 4, up 0 to get my last point. And then I'm just going to connect the dots. And lo and behold, we get a triangle. And what I kind of like to do is label the points just to make sure that, you know, I can recognize them later. Okay. So there's my shape. If you have sides that are vertical or horizontal, you can just count the length. So I can count the length of one of these sides. This one right here is straight up and down vertical. I can just go, okay, 1, 2, 3. Well, that side is 3 units long. Great. That cuts down on the work that I have to do, because I know that side's 3 units long. But to find my other 2 sides, I'm going to need to use the distance formula 2 times. 1 time with these 2 points, and another time with these 2 points. So reminding ourselves of the distance formula, the square root of x2 minus x1 squared plus y2 minus y1 squared. Here we go. My first time through, I'm going to use the points 1, 1 and 4, 0. That'll find this side length for me. Okay, so we've got x1, y1, x2, y2. I also noticed some of the people that had trouble with this sort of distance formula problem. It was a lot to do with labeling your points. Make sure that your x values are x's and your y values are y's. I saw some people go x1, x2, y1, y2, where it's xy, xy. Okay, so here we go. Big square root. x2 minus x1. So 4 minus 1 squared. And then y2 minus y1. So 0 minus 1 squared. 4 minus 1 is 3. 0 minus 1 is -1. Remember to keep your square root involved here. 3 squared is 9. -1 squared is +1. Adding that together, we get the square root of 10. And now in this case, since we're finding the perimeter, I don't want to add the square root of 10 to stuff. That doesn't really compute well or give me a useful number. So I'm going to put into my calculator square root of 10. So square root 10 we get is approximately 3.16. Remember the squiggly equal sign where they're both squiggles is like approximately equal to? So there we go. 3.16 is what we have approximately here. Then we're going to do the same thing, but for these 2 points. This is going to be my second distance formula. So we're going to hold on to this. We know that this side now is 3.16. My second distance formula is going to be with these two to find this length here. So we have 1, -2, and 4, 0. So same as last time, we're labeling our points. x1, y1, x2, y2, and we're doing this all again. Big square root. x2 minus x1 would be 4 minus 1. y2 minus y1 is 0 minus -2. So 4 minus 1 is 3. 0 minus -2 is +2. Three squared is 9. 2 squared is 4. 9 plus 4 is 13. And then just like I did with the 10, I'm going to stick this into the calculator because the square root of 13 is not particularly useful to me when I am finding a length or a perimeter. So square root of 13 is 3.61 approximately. So now I know that this side up here is 3.61. And now I'm ready to find the perimeter. So step 3, add them together. And you want to make sure that you're adding all 3 sides together, not just the 2 that we worked so hard to find, but also the third one. Otherwise, your answer doesn't work out. So we want to go, perimeter is going to be 3 plus 3.16 plus 3.61. So it's always a good check. You should be adding the same number of things together as sides that you have. So we should get 9.77 for our perimeter. Or if you were supposed to round to the nearest tenth, it would be 9.8. So pay attention to whatever they ask you to round to. This would be the nearest hundredth, which is kind of what I prefer. But if you're on big ideas, if you're asked to go to the nearest tenth, then you would round to 1 less decimal here. You'd go to 9.8 instead. Okay, so that's an example of perimeter in the coordinate plane. So looking at that process, are there any questions at this point? Any numbers that don't quite make sense? Or steps that we don't quite follow here? Okay, so then let's do another one. We'll try this one together. But it'll be one of those ones where you can kind of go at your own pace as well if you would like to. Move some stuff around. We'll do one more of these. Paper everywhere. That is what life feels like. Paper everywhere. Okay. So this one's going to be the same idea. I'm going to give you some coordinates. So we've got 1, 2, 3, 1, -2, -2, 0, -3. And we want to find the perimeter of this shape. So if you are at a point where you feel like you can get started on this and do it on your own, feel free to do that. If you would rather follow along with me, I will start by plotting the points. Okay, so starting with plotting the points. What do we notice about this shape? Does anyone notice something? What kind of shape it is? Or what does it look like it could be? Rectangle. So if it's a rectangle, do I have to find all four sides and do the distance formula 4 times? I know this is a rectangle. Am I going to have to do the distance formula 4 times here? Sounds like a lot of work. If it's a rectangle, we know that the opposite sides are equal. So no, we do not have to do the distance formula 4 times. I can just find the distance between, or find the length of one of the long sides. And then I can find the length of one of the short sides. And then I automatically know that the long sides are the same and the short sides are the same. Usually in a problem like this, we would tell you that it's a rectangle. So that we know we don't have to do that much work. So I can just find short side. And then the distance between these for the long side. Okay. So why don't you guys go ahead and get started here on the short side using the distance formula between 1, 2, and 3, 1. Go ahead and try that on your own. Remembering the distance formula here. I'll put it over here in case we've forgotten. All right. So if you're going along and doing it on your own, you can look up here to check your work. At the very end, your answer should be about 2.24. So if that's what you got, you're on the right track. If that's not what you got, if you got something else, then go back through and take a look. Maybe you accidentally said that the square, or that -1 squared was -1 or something like that, but it should be +1. Then we're going to do the same thing with the long side. So we'll take the points 3, 1 and 0, -3 and do the same thing. Yep, you're right, Christy. It comes out to 5. Yep, so that long side comes out to a nice whole number, which sometimes they do, sometimes they don't. But that was a nice case. All right. So then our third step is add all together. But make sure that when you do your perimeter here that we're adding 2 of each of these. So if you would rather multiply it by 2 first and then add the 2 things together, you can. Or you can just go 5 plus 5 plus 2.24 plus 2.24. To get 14.48. Or if you were asked to round to the nearest tenth, it would be 14.5, depending on how you're asked to round. But yep, 14.48. Awesome. So that's perimeter in the coordinate plane. And that's pretty much the rest of the stuff in 1.4 that we're going to talk about. So we're going to shift gears a little bit. And we're going to start talking about angles. Just kind of introducing it today, angles. All right. So you've probably seen angles somewhere before. If you haven't, they typically look like this. And there's some important parts on an angle. Angles are made of 2 rays, typically, or it could be a line and a ray coming out. You know, there's possibilities here, but typically it's defined by 2 rays. So we'll call that A. The most important part of an angle is this right here, the vertex. That's the most important part when we're naming an angle. So there's a couple different ways we can name angles. The first way is with 3 letters. When you do it with 3 letters, though, you have to be careful. The vertex must be the middle letter. So for example, in this case, for this particular angle here, we could call this angle ABC because B is in the middle and it's the vertex. Or I could switch the A and the C around and I could call it CBA. But I could not call it BAC. Or anything that does not have B in the middle. B must be in the middle because it is the vertex. Okay. So that's kind of a surefire way to name an angle. It's always going to be right if you name it with 3 letters. It's always going to be well-defined enough if you name it with 3 letters with the vertex in the middle. The second way that you could name an angle is with just the vertex. But when you do it with just the vertex, you do have to be a little bit careful. I could call this angle here with the A, the B, and the C. I could call it angle B. But if I had a picture like this, where I have something like this, in this picture, angle B is not descriptive enough. Because if I said angle B, you wouldn't know which angle I was talking about necessarily. I could be talking about ABC, I could be talking about DBA, or I could even be talking about DBC. So there's like 3 angles in this picture that I could be talking about here if I just said angle B. So in this picture, angle B doesn't work. Yeah, this says just the vertex. So in a picture like this, using just the vertex letter works. In a picture like this, using just the vertex letter does not work. So it's always safe to just label it with the 3 letters. And then we have one final option for naming angles. Occasionally you will see
Miss Lindell.
Yeah, what's up, Christy?
Why doesn't it work?
Why doesn't it work here?
Yeah.
Because if I just said angle B, you don't necessarily know if I'm talking about this angle or this angle or the whole thing. Yeah, so it's just not quite clear enough. But if I said ABC, you would know for sure that I'm talking about this part. Or if I said ABD, you would know for sure that I'm talking about the one over here. But yeah, good question. All right, and then the last way is that sometimes you'll see like a little number in the corner of the angle. Like, so the last way is with a number. So sometimes you'll see a picture that looks like this with like a 5 in the corner. Or a picture that looks like this with a 1 in the corner. Or something like that. So I could call this angle 5. I could call this angle 1. Okay. Sometimes you'll see something with like, degrees or something though. And that's if you see like, this is A, B, C, and you see that this is like saying that 60 degrees, that's the measure of the angle. We wouldn't call this angle 60 because it's telling me that it's 60 degrees. It's not telling me that that's the name of the angle. So if you see a degree symbol, that's different. But if there's a number with no degree symbol, it says just, that's supposed to be a J. Okay. But if we see just a number with no degree symbol, then you can name the angle with that number. If you see a number with a degree symbol, this is not angle 60. No. Okay. Any questions about naming angles that come to mind at the moment? Okay. We're almost done. All we have to do now is talk about acute, obtuse, right, and straight. And if you do have any questions, either unmute yourself and say so, or type in the chat. Okay, so this is going to be classifying angles. So we've got some words to classify angles. The first word is acute. The second word is obtuse. The third word is right. And the fourth word is straight. Have you heard these words before? If you have, type yes in the chat. If you have not, type no in the chat. All right. Looks like a lot of us have heard these words. That's a good sign. So this will be an easier topic for you guys. Acute. Less than 90 degrees. Or sorry, that's the reason. Less than 90. So if you're thinking of acute, you're thinking of angles that are tiny and cute, right? You might have heard that way to remember things before. Let's say this was a 30-degree angle. That would be an acute angle. Or even an 80-degree angle would be acute. Obtuse. Greater than 90. So we might have a 120-degree angle. Or we might have a 97-degree angle. Anything that's bigger than 90 but less than 180. Okay. Then we have the right angle. Exactly equal to 90. Less than 180 because when we talk about a straight angle, you'll see that a straight angle is 180. Yeah, so that's kind of a new, like, might be new for geometry for you guys, that an obtuse angle is less than 180 because a straight angle is 180. All right, and then a straight angle is an angle made by two opposing rays here. And it's exactly 180 degrees. So it looks like a straight line. And if you think about it, right, a circle would be 360. So half of that would give you 180. So it's kind of like half a circle's worth, halfway around. 180. If you're doing a 180, you're turning around, right? Okay. If you're doing a 360, you're coming full circle. Those are all of our angle classifications there. So we want to name angles. We want to classify angles. Any questions about the angle names? Okay. So here we go with getting to the assignment here. And I think I need to grab a link real quick. Oops, not that one. This. No, not where I wanted to go over here. Okay. Anyways, on IXL, we need geometry. All right, so your angle vocabulary. is going to be in IXL for today. Your other assignment is your 1.4 assignment is going to be in Big Ideas, and it's very short in Big Ideas today. It's only like 8 questions, I think. And some of them are about polygons and like saying how many sides the polygon has. So really, it's only a couple perimeter questions since they tend to take a while. So yeah, so there's our assignment for today. So here it is. It should show up in Google Classroom now. Make sure that you log in with Clever. And you now have until 10:55. You can go and work on this. Come back at 10:55 and we will do our exit ticket and our HSBP. You do need to be here for HSBP today. I think it's a presentation we have to go through or something like that. So please come to HSBP. Otherwise, you are free to go start working. If you have questions on anything or you want to go over something with me or anything like that, feel free to stick around. Otherwise, see you at 10:55.